Welcome to our video on combinations and tables. So a combination is a collection of things in which the order does not matter. And so I need you to write this down on your recording sheet and make sure that you show an example and a non-example, and you may have to watch this video to really get an example and a non-example. And then you need to make sure that you write that on your recording sheet. If you have any questions, you can always ask your teacher or any other teacher that you need to ask. And make sure that you do all the parts of your homework, including your Think Through Math, and make sure that you are doing all the parts of your homework so you can get credit for it in the classroom. Let's continue on. So let's look at this table. The table shows how much three sisters earned babysitting. So we have Chandler, Jody, and Trisha. Jody earned twice as much as both Trisha and Chandler. How much did the three girls earn? So first, I have to figure out how much Jody earned. So I'm going to rewrite my question as a statement, and I'm going to say the three girls earned blank, period. So Jody earned twice as much as both Trisha and Chandler. So first I have to figure out how much Trisha and Chandler earned. So that's 35, and then twice that. So that's going to be 70. So now I know how much Jody earned. Is that my answer? No, because it says the three girls earned. So I have to take the 35 that the two girls earned plus the 70 that Jody earned, and my answer is 105. That's how much the three girls earned. So first I had to combine the two girls, figure that amount out, double that to get Jody's, and then I had to do 70 plus 20 and then plus 15. Or you could do the 15 plus 20, which is 35, plus the 70. Let's look at this one. Alexis worked at the bounce house and keeps record of the total number of children that bounce on the trampoline at different intervals. How can Alexis find the number of children that attended the bounce house after it was open for 8 hours? Well, this table is going to have a pattern. So I've got 3 hours, it's 24, 5 is 40, 7 is 56, so 8. I have to figure that out. Well, I know that 3 times 8 is 24, or 24 divided by 8 is 3. 5 times 8 is 40. 7 times 8 is 56. So, how can Alexis find the number of children that attended the bounce house after it was open for 8 hours? So I know that this is a times 8 or divided by 8, depending upon which way you're going, table. So 8 times 8 is 64. So the number of children that attended after 8 hours is going to be 64, because this is the number of hours, this is the number of children. Next, look at the numbers in set C, and, that's supposed to say and, look at the numbers in set D in the table below. Based on the information in the table, how would you find the missing set number in set D? Well, first I'm going to look at the table, and I'm going to say, okay, 39 and 33, 29 and 23, 19 and 13, so 9 and blank. So I'm going to say that going from 39 to 33, that's going to be a difference of 6 if I subtract. So this would be minus 6 goes there. So let's see if it works. This is going to be a minus 6 because 23 plus 6 would give me 29. So this would be a plus 6 side. So this is going to be plus 6 gives me that, or this minus 6 gives me. So if I take set C, minus 6 gives me set D, Or if I take set D and add 6, it gives me set C. So that's pretty much the pattern I'm feeling. So let's see. Add 10 to the number in set C. Well, I didn't add 10 in anything, so that's definitely not it. Subtract 6 from the number in set D. So if I take don't always choose the first number. Choose a number down here in the middle because they try to trick you with that. So if I take set D, well, I know that set D is plus 6, not subtract 6, so that cannot be it. Add 6 to the number in set C. So if I choose 29 and I add 6 to that, 29 plus 6 is not going to give me 23. So that is 100% wrong. If I take a number in set D, I'm going to go with 23, and I subtract 6, that definitely does not give me set C. So that does not work. Subtract 6 from the number in set C. Set C minus 6, does that give me set D? Yes, so that is the correct answer. Okay, let's talk about combinations now. So, if I'm looking at this, it says Ms. Hearn is making combinations of Halloween snacks for her students. She has 2 types of candy, candy apples and skeleton bones. She also has 2 types of cookies, pumpkin and scarecrow. If she chooses one item from each category, how many combinations can she make? So if I took skeleton and I added a cookie, then I took skeleton and I added a cookie, I took apple and I added a cookie, I took apple and I added a cookie, then that would give me 1, 2, 3, 4 sets. I can do that a whole lot easier without getting all kinds of messy. I'm going to make a little bit of a table, and I know that I have some choices. Okay, so I can choose 2 types of candy. Candy apples, so I'm going to say candy apples, and skeleton bones. Those are my 2 types of candy. So actually, I'm going to title this up here candy. And I can choose candy apple or skeleton bones. And then I'm going to choose cookie. And I have 2 choices. I can either choose a scarecrow, so I'm just going to put scarecrow, or a pumpkin. P for pumpkin. And then I have no other choices over here. So basically, there are 2 choices here and 2 choices here. If I take those 2 choices and multiply them, that gives me 4, which is the same thing as dragging each one of these out and matching them. So much faster. Let's look at this again. Miss Farrell is making Halloween goodie bags for her class. She has 3 types of candy: tombstone, candy apples, and skeleton bones. She also has 2 types of cookies, pumpkin and scarecrow. If she chooses one item from each category, how many combinations can she make? So I could do this with that. There's one combination. This with this. There's another combination. This with the pumpkin. This with the scarecrow. Then I can do the apple with the pumpkin and the apple with the scarecrow. And then I could count. And I could say I have 1, 2, 3, 4, 5, 6 combinations. Or I can do it a whole lot faster. I can make my categories again. So I know that I have candy. And I have cookies again. This time I have the skeleton cookie, the tombstone cookie, and the apple cookie. Or candy, sorry. And then I have a pumpkin and a scarecrow. I know that there are 3 in this category and 2 in this category. If I multiply them together, that gives me 6. Done. That's how fast you can find combinations. Let's look at another one. Mrs. Trotter is making Halloween costumes for all the teachers at Walker. She has 3 types of hats: pumpkin, silly ears, and one special crazy hat. She has 2 colors for the body: black, or gray. The teachers can also pick 4 types of shoes: princess, slippers, boots, or feet. How many different costumes can she make? Well, I'm going to make my categories right here. She has 3 types of hats, so I'm going to say hats. She has pumpkin, silly ears, and special crazy. She has 2 colors for the body, so I'm going to say body colors. She has black or gray. And then she has shoes. She has princess, slippers, boots, or feet. Now, I know that there are 3 in this category, 2 in this category, and 1, 2, 3, 4 in this category. I can do 3 times 2 times 4. 3 times 2 is 6, times 4 is 24. So there are 24 combinations that you can have. So if you put them into the different categories and you say how many are in each category and you multiply all the categories by each other, you get 24 choices. That's how easy combinations are. So if you have any questions, again, ask one of your teachers. If not, have a great evening.